I took a video to show how just by demonstration we could find that it's true that the derivative of sine is cosine. And you can use that same effort to find that the derivative of cosine is negative sine. But what if I want to find some more advanced things? What if I want to find like the derivative of tangent? How would I go about doing that? Well, all we need to do is remember that tangent isn't tangent. It's not. That is a shorthand for the sine function divided by the cosine function. And what better way to apply a recently learned quotient rule than by doing it this way? And all we need to do is remember that when you have two functions of x, you need to use the quotient rule if one's underneath the other, and that's u prime v minus v prime u over v squared. Okay, so the u is the numerator. You can tell me what the numerator is, it's sine. I realize I sound like I'm talking down to you guys right now, but I'm really serious about this. U prime, the derivative of sine is cosine. That's just a rule that we learned, and we showed it by inspection in this lecture series. And the v is cosine, that's the denominator. V prime, the derivative of cosine, is negative sine. So let's just plug it in. U prime v is cosine cosine, so that's cosine squared, minus v prime u, that's sine and sine, but it's a negative, so it becomes a plus sine of x squared, all divided by v squared. Well, cosine plus sine is equal to 1. So cosine in the denominator is also known as secant. And you might see it, I always harp on this, you might see it written here, secant squared of x. But that's stupid. They need you to see that it's outside of the function, which it is here. Okay, so the derivative of tangent, I'll just write it here, is secant squared. And this will be written on a little hot chart in the front page of your book, and that's probably all you use. But if you can't derive this, you're not going to make it. So you should practice with these trig functions like this. Let's try another one. What's the derivative of secant of x? Well, we know that it's not secant, is it? It's not secant. It's 1 over cosine of x, isn't it? And we can use the quotient rule again. Our u is equal to 1. Our u prime is 0. Our v is cosine. Our v prime is negative sine. So let's write it out. U prime v minus v prime times u all over v squared. Why am I writing a v? Okay, let's condense it down a little bit, shall we? 0 times cosine is 0. Double negative becomes a plus, and a times 1 doesn't really make sense. So we end up with sine over cosine squared, which I'm going to write as sine of x over cosine of x times 1 over cosine of x, like this. So we can find that it's equal to tangent secant. And that's the derivative. So you see, applying the quotient and product rules into the trig functions becomes very useful to us, because in the future, I'm going to be doing problem sets, and I'm going to slowly stop deriving this together because it takes too dang long. That's the truth. I don't want the videos to be that long. But we can say the derivative, what was that, of secant is tangent secant. It has itself in there. Isn't that weird? And if you want to do another derivative, you would look in here. I'm going to challenge you to give that a try for your own lecture, but let's go ahead and move these up into the rules we know, and going forward we won't have to do it over and over.